Hi all, I'm Dr. Sujya, Assistant Professor in the Department of Computer Application at Dr. S.N.S. Rajalakshmi College of Arts and Science. Today the lecture video we are going to see is about Introduction to the Binary Tree. So binary tree in data structure is an organization of the data in the hierarchical fashion, and the binary tree has a name since it has two children which are called as the left child and the right child. Topmost node is called as the root, and the node which has no children are called as the leaf. So in this diagram, it is clearly explained the topmost node, which is denoted as A, is the root node. B and C are the left child and the right child, and the B bearing D and E and C bearing F and G are the leaf nodes. So why it is so called as leaf node is further there is no child nodes present for the node. So this is all about a binary tree. And the types of binary tree in data structures are the rooted binary tree, fully binary tree, complete binary tree, and almost complete binary tree. And we have squeezed binary tree. So rooted binary tree is a tree which satisfies the following two properties. The first one, it has a root node, and then each node has two children. So the rooted binary tree should have two children, left children and right children. So here A is the root node, B and C are the children node. So B is bearing D and E leaf node, and C is bearing F node. The rooted binary tree should satisfy the two rules, and this is all about the structure of the rooted binary tree. Next one we are going to see is fully binary tree. So here two comparisons are being given, which is right and which is wrong. So basically fully binary tree which has 0 or 2 children, which is considered as a fully binary tree. And in this left diagram, if you see, A is bearing B and C child node, B is further bearing D and E, and C is bearing H, and E is bearing F and G. Here, what is the error it has is uh, A is bearing B and C is right, B is bearing D and E is right, and E is bearing F and G is right. C cannot bear H. Unless C has both left and right child only, we can move on with E. Before completing C, we should not switch on with the next node of the binary tree. So this is what is the uh, error that has been present in the left of the binary tree. Next is the complete or the perfect binary tree is every internal node should have exactly two children, and all the leaf nodes should be of the same level. So for example, in the first diagram, if we see A is bearing B and C, and B is bearing D and E, and C is incomplete, it does not bear any leaf node. So this not satisfies, or it is not said to be a complete binary tree. For a complete binary tree, A has to bear B and C, and also B and C has to bear two leaf node, leaf children node, or two leaf nodes. So it's all the binary tree should have two nodes for each of the topmost nodes. So this is all about a complete perfect binary tree. Next, the almost binary tree should follow or should satisfy two properties, that is all the levels are completely filled except possibly the last level, and the last level must be strictly filled from left to right. So in this example, if you see A, the topmost node, bears B and C, and B further bearing D and E, and C satisfies only the leftmost node F. But this condition is wrong almost, and in every binary tree, first the left node has to be filled, and then we have to fill the right most node. So but in this previous diagram, C is first filled with F, which is the rightmost node. This is not the right one. First, C should fill the leftmost node, that is F, which is the rightmost node. This is not the right one. First, C should fill the leftmost node, that is F, the leftmost node, that is F. Only then the rightmost should be filled. So this is one of the error that has been focused in almost complete binary tree. This is also a binary tree, but as per the rule of a binary tree, the leftmost node should be filled first, followed with the rightmost node. So this is said to be a complete binary tree. So the next we see is